This is Chapter 8, Problem 27. So in this problem we have Tarzan swinging from a vine. Tarzan has a weight of 688 newtons, and he is swinging from the edge of a cliff down a vine that is 18 meters long, and he's changing his height by 3.2 meters. Now what we're trying to do here is we're trying to figure out whether or not the vine will break, so we're looking for the tension in the vine. I've written down all of the pertinent information. The important thing to remember on this problem is that we're actually going backwards a little bit. We're going to use some energy conservation at the start, and then we're going to move into centripetal force, things that we talked about before. The net force acting on Tarzan is going to be a centripetal force. It keeps him in uniform circular motion. That's going to be equal to the tension inside the vine minus his weight. So we know that the centripetal force is equal to mv squared over r. So we need to get his velocity from his change in potential energy. So the first thing I did was solve for the velocity. We know that his potential energy, his energy initial, is all potential energy. So energy initial is equal to potential. That's equal to mg. Keep in mind they gave us the weight of Tarzan, which is 688 newtons. And we're going to multiply that by his height change, which is 3.2 meters. And that's going to be equal to 2201.6 joules. Now we're going to set the initial energy equal to the final energy, the initial energy equal to the final energy through energy conservation, and that's 2201.6 is equal to 1/2 the mass of Tarzan, which is 688, divided by 9.8 times the velocity squared, and that will allow us to get the velocity of Tarzan. With all of that data, we get a velocity of 7.92 meters per second. Now we're going to substitute that into our tension equation from before. So the tension minus 688, so tension minus Fg, tension is up, Fg is down. That's going to be equal to the centripetal force, which is now going to be the mv squared over r. The mass of Tarzan, once again, is 688 divided by 9.8. The velocity is 7.92 squared divided by the radius, and the radius is the length of the vine. So the radius is 18. We end up getting a tension equal to 932.61 newtons, which means that the vine will not break.